Hello everyone, my name is Shubhro and it's the last revision of my forming, and after that I will just gonna refer to this video and then gonna go to the short notes. Only these things I'm gonna do. So currently let's get started in the video. The main thing that you need to understand for metal cutting is that it's basically formula based chapter. Okay, now from these are the numbers that have come 2, 3, 3. So 1 mark will definitely come. So rest assured. Ravindra Subha has written this. So metal forming. So it's not we are just not casting it up or not do casting or something, but we are just forming it in some way. So it's a between something, there is the these are the bulk formation and one these things miscellaneous. Okay, and advantages of this material is a zero negligible material wastage and possibility of required direction gain orientation possible because we are just forging it. And then in cold working strength is hardness increases, water increases, and in hot working hot increases, ductility increasing. Okay, next. So how is the cavity, that is the ingate, that is the cope, spur, cope box. So all these things. For temperature, something is better. Solidification, how is happens liquid. Then yeah, that phase change happens from liquid to solid happens, and then it's outside the mold. It's outside the mold. Always remember from this point it is outside the mold. Okay, and every other thing also that you can see here is the grain formation that are given. How's that? So like how quality and cooling. I don't have to tell these things. And how machining, casting. This is casting. This is machining. How is grain formation and this is. So grain flow is uninterrupted and well. So that's why you are just using. And limitation, forge energy is required very high. That's and highly automated. Manufacturing difficulty, cost, and other processes only manufacturing uniform. Expect forging all other processes can only manufacture uniform. And undercut and crosshole are not possible. Crosshole and undercut are not possible here. Non-uniform thickness. Okay, these things are jargon. So now temperature doesn't matter. So these two things mu 0.1 to 0 is the coefficient of friction. And there where is greater than, so steering friction, what is the steering friction? 0.6 to 0.7. So now good quality surface, better dimensional accuracy for poor quality surface, and poor dimensional accuracy. Hot working less than 0.3 melting point temperature, and warm working between 0.3 and 0.6, and all this thing. Strength and hardness increases in cold working. Here malleability and ductility, where strength and hardness here drops. Malleability here drops. Okay, how is happening? Dislocation, slipping, twinning. What is twinning? You need to see. And then the recrystalline temperature. What is say new grains, like 1/3 to 1/2 of metal crystallization temperature. And for lead, tin, and zinc, cadmium, so hot working is under room temperature. And for titanium, it is 3000 celsius, like 1 to 3. And so below 1/3 it is cold working. Below 1330 is for titanium, it's cold working. And length changes, it's like brittle material. Stress diagram here it is given. You know that it is the upper covalent lower EL, and then friction starts and all things is and then this is the function of E. These things are written. Then ductility, original minus reduction of cross sectional area, original minus final upon original. Okay, now brittle material. How is it for brittle material? UTM testing. There is the fracture that happens here, and this is the points. It's still A. What are the things? So stress, strains. Now the main thing that you need to see here, EIT, total, it is strain, matlab plastic and strain. Like this is the plastic, this is the strain. Okay, maths will come. E total is the plastic after some time. And stress diagram for compressive loading. This is the compression diagram, this is the tension diagram. 45 degrees of fracture happen, sigma y, all these diagrams. So I don't, the main points I will just gonna cover. Strain, engineering strain, it is A0 by A1 strain. And for diagram 2 into ln, d0 by d2. Okay, 2 into ln divided 2. And this is the stress, is S plus, where S key, S is engineering stress, stress is S is engineering stress. How is coming? You can see here. So this is the engineering, first at initial engineering, then the increase true stress key instantaneous point, and engineering stress key at some point. This is the change that is happening. It is the main that was there. So like engineering and true stress relation is true stress equal to engineering stress into d initial upon d final whole square. Okay, no, moving on. Strain is E into ln L1 by L0. Okay. Next, true stress strain curve that we are given also till like plastic deformation, strain hardening, necking zone, all these things. This formula, like power law equation, this is called K into epsilon strain to the power n. N is strain handling capacity, strain handling, strain constant is true strain and true strain. All these values are been given. Sigma equal to strain handling equation. It is the point, and L value you can see from log E1 minus 2 by log E2 standard exponent, and it is plastic deformation zone that has been given. Flow stress, average flow stress. So plastic deformation zone, there is a flow stress happens, so 0 to E like flow stress, that is K to n plus 1. It is average flow stress. Flow stress is equal to yield stress. Flow stress is equal to flow strain or yield strain. And area reducing forces should not reduce. Area in reducing forces should not reduce. Reality do not do that happen. Like all this jargon here. This is the ultimate point. Equal to E0 by A1. And in value from there you can get 1 by E. Strain rate like delta L by L0. No unit. E no unit, but strain rate is seconds mass. Volumetric constant, that is for volumetric constant, how the volume changes in 3 directions, so it is 0 because total volume final and initial, that is same. Then for the cylinder there is with 2 time dimension change, E in total dimension length plus 0. All these values there, just we have just whatsapped it, just we and get there. We are just gonna take a minute 15 page. Now coming to the rolling part, rolling. So this time, this direction, the velocity will be higher than this side. Okay, compressive force. Okay, mandatory things before rolling. You know that the two dimension has to be same. So what will happen that you can see. Then this side. So alligator effect can happen is they are not different. Resistance force like this we get an with a high said that bending force creates single vertical, and roller must be perfectly cylindrical. Length of the rod, width of the metal. Length of the roller has to be greater than width of the metallic strip, and force from the same earth. Presence of friction between roller and strip material dragged in the roller. Surface velocity is greater, I can say it. And then assumption in rolling, that is the material is incompressible. Incompressible original final length and the breadth is same. Plane strains in rolling and deformation occurs in z direction, in z x y z direction. The deformation when the fundamental placed in rolling, the fundamentals are at entry point B is the exit point, that is red zone is the neutral zone, then D is the diameter of the roller, R is the diameter, H0 thickness before rolling, and then delta H H0 minus HF. Okay, volumetric sign coming to this point. V0, no, V0 is greater than V is greater than V0, and we have to be same. We have to be same. Angle of bite angle made by deformation zone. Deformation zone bite angle. This is the bite angle. Okay, to the roller deformation center line. B equal to tan mu, that is a friction angle, and then L0 is a length strip after an velocity, and plane strength constant of y B is constant, that you can see as temperature thickness is increasing, resistance decreasing, and it's function of alpha and by alpha angle and D. Natural plane analysis, this is the natural plane that has been said that velocity would be 0 and L0 by L1 equal to H0 by H1, and discharge would be same. Discharge should not be remain constant at that place. So rate hardness and these things. Okay, sprint rolling, sleep in rolling when V is greater than V0, like V and V0 are not same. Sleep in deformation, difference between velocities, and sleep is relative velocity, we can say. In this idea of relative velocity, alpha is different velocities and beta is greater than. Okay, these things are know that minimum backward slip. Backward slip matlab V is greater than V0. V is this side, there is a V, like it is V greater than V0 by V. So from here it is get, and from far side this velocity is forward slip, and the condition of a successful rolling move lagging zone, from lagging zone VR value has to be greater, VR roller value has to be greater than initial favorable condition leading zone, that is V1 value greater than has to be roller. This value is highest, then this value, then this value. Okay, at entry as the deformation, the angles, and we are getting then mu equal to greater than tan beta, we are getting pressure angle is 1 by slip. Now friction profile in rolling. So favorable condition, natural plane, you know, natural friction, and this is variation of pressure in slip across different zones. So it's the pressure that how changing, you can see here it says neutral plane, that is the highest, but in slip, in neutral plane, the slip is lowest. Okay, rolling pressure stress with the metering plate, and after natural plane the strip will drag the roller, so there will be pressure drop. So this is the point, that is velocity of the slip backward zone as neutral shift toward the right, the different forward very less, you know that the laser is less. Okay, these angles we are just calculating, so all this thing you can see later, but the first thing that you need to see is that tan alpha is del h by del h is h2 minus h1 upon r. R is the roller radius, r will be roller radius as much as I know. So O1c, that is O1c, that is r minus del h by 2. Okay, this is the roller radius, and del h equal to d into 1 minus cos theta. You can see f is d plus, you know, this is two things that is different, and work done is f cos theta into dl. Okay, f cos theta into dl. Now area and length, area are radian, these things are not. This formula is important. The length arc length depression, that is the how much length the projectile area, length of the plus deformation zone. In this zone, how much is the length would be, that is the formula is r into delta h. R into delta h. Okay, maximum reduction possible, that has been calculated here. Maximum calculation is if cos alpha has to be greater than sin alpha, so beta has to be greater than sin alpha. Okay, okay. Del h max, that is mu square. Mu square, that is the main. Okay, number of passes del h by del h max. Okay, tandem rolling we are using for maximum elongation in factor in rolling. K is L by L0 and h0 by h1, like the last thickness by first thickness. Okay, like final by k to the power n equal to h final by h last. Let's see the, it's, yeah, h0 into omega 0 by h1 omega 1 weight into weight and weight into. So true stress strain engineering, true strain in rolling ln h0 by h, original thickness upon final thickness, and L is r delta h, you know, projectile area L into del omega. So force equal to force P average into L into omega. Pressure in rolling, you know, these things F equal to pressure into area. Now there is a roll separating force. How is much, like rolling there, when rolling happens, how much force would be there that the roller will side view, that is the front view. This is the side view, this is the front view, that how the rollers are coming. So this is something. Method to reduce roll separating force, what are the recrystallization temperature. So why the temperature has to be greater than recrystallization temperature. Reducing diameter of the cylindrical roller, applying a back and front tension, you know, mu equal to Poisson. Reducing the friction, mu into h, del h max equal to mu square, so mu we can reduce. So now the roll separating force, this is the radius, this radius plus h, so 2r plus h. Okay, average rolling force equal to f average equal to p average dot d into L, that is the area that has been, that is the L and d. Omega into L, that is the omega into L. Width into length, how much is the length area depression. Okay, average flow stress of the material given y equal to k into, you know, average flow stress y bar f. Now how width remains constant, how much the force, this is the compressive force that is happening, there is a two tensile force that is happening, and all these theories are von Mises theory applicable, and these things I don't see, but the f average is y by f into omega into L, that is the flow stress plus y by f k 2y3 2y root 3 into y, that is the plane strain condition that is happening. So these are the two formulas that I need you to by heart. Just write down where somewhere, or write down in your brain that this formula I have to remember. In notes also there I have marked it, In rolling somewhere I have marked. This is the formula that you need to remember. Okay, just see and have a look. It's 15-minute video, 10 minutes. You can keep 10 minutes to daily. 2 or 4 doubts will be able to. That is the final relevant plane strain rolling force. The strain hindering material that is Y bar F, and normal plastic deformation, that is Y. Now power required is power equal to force into velocity. Okay, Newton meter per second. What is joule per second? Joule equal to Newton meter per second. Force equal to tau into omega, we can also say, for one roller. And for two roller, 2 into tau into omega. For two roller, there will be two roller, and omega equal to 2 by n by 60, tau equal to F average into velocity, and 0.5 is by default for the value of A equal to lambda into L. A equal to lambda into L, and lambda value there is 0.5 for hot rolling, 0.4 for cold rolling. And types of rolling: too high rolling, there will be too high rolling, that is there will be production. Okay, these things you have to say. I will not gonna just go through that. Reducing the rolling force, we have also said L into 2 root 5 how is happening. So maths, okay, go through this. Okay, go through this by you. I cannot understand you those things right now. That is the tube drawing. There is two things: tube sinking, there is a waviness, that is not, there is a mandrel. So mandrel is used. Some wire drawing is formula same as wire drawing formula, that is B equal to mu into cot beta. There is something that is missing, you have to see at the note. Types of mandrel, that's conical, and this. And reduction: 2 beta is cone angle, you know, that is a beta. Alpha is semi-diangle, theta is diangle. And there's a formula, that is the sigma drawing state, that is Y bar A flowing state plus 1 plus beta minus 1 minus H1 by H0. It is for, see, for tube drawing, this is the formula. And then beta value is mu plus minus mu by 10 alpha. There where is it is fixed, that is fixed value, there is it is read that where it is fixed, then it is this value, and where it is moving, this value. Okay, this value. Okay, ideal tube drawing, that is mu equal to mu1 equal to 0 and mu2 also 0. Then y bar equal to ln h1 by h0, because everything is 0. Mu equal to 0 and mu2 equal to also 0. So beta 0, and it's beta 0. Then what the value will be? Mu1 and mu2 equal to 0. Then it is 0 by 0, that is 0. h1 minus h2, that is also gone. So ln, this drawing state that is coming, then drawing state y bar f ln h by h0. Then some maths, then forging. We are coming as forging. There is a true force, there is a sticking force, there is a drawing force. To original dimension, final dimension, all these things, blah blah blah. So this is the formula: df equal to d0 into h0 by hf. Okay, this is the h0 by hf, and hf equal to h0 into d0 by d0. Application, you can see there is a tube drawing, simple, costless, that is the flash that has been made. Drop hammer, there is a certain impact load that will happen. Okay, then based on classification, there will be hammer mass, drop also pressure, diameter of the hammer, potential cancel. So W into work is F into H0 minus HF. Based on the type, open die forging diaphragm, open expansion will be less, expansion force will be less for open drawing, stick to the die surface. And then this is the diagram, you have to see it. I will not gonna tell you these things. It is a bottom die, this is the die. So the new volume raw material 10 to 20% greater, that will happen. Impression forging, classless forging, these terminologies conventional, go for it. Analysis of forging, that is the material, there is a bristling for operation, there is a friction happen, there is a friction happens, sticking friction happens, sliding friction and slitting friction. So bottom die, and there is expansion force, that's top die. So dp and df, there's outer post normal force reducing, so that the region up also reducing, so region mu p also reducing. At outer there is a sliding friction, and inner there is a sticking friction. And f is the h value is reducing, f value is, so h value will reducing, area will increasing. When the area is increasing, h value is decreasing, that is, you know. And y max is y bar into a bar f, and sigma equal to k bar n, e equal to these things. Okay, there is one formula, y bar equal to 2 by 3 Von Mises criteria, y bar. So y bar equal to 2 by 3 y, that value has come. So now xx, this formula you need to remember. X is, what is the value of x? This is how much go. So I think a minus h by 2 mu ln y by 2 mu, and p average y bar equal to 1 plus mu y by mu 2. Yfk equal to epsilon for strain hydrogen and y sigma y force. And forging force in circular dies. R is equal to R into 1 by h by 2 mu ln 3 by mu. So sticking friction 0 to R is sticking friction, 0 to R is sticking friction, and after that R is to R, R is to R, there is a sliding friction. There is a force that y bar into F 1 plus 2 mu R F by 3 HF. 2 mu R F by 3 HF. That is the flow. YF sigma y plastic. Okay. Forging in flat surface, H equal to decreases forging length. And how is happening? There is a sticking friction zone, and A is equal to AF into, and all these things. Important types of forging, these things, just formula. Go through that. Then 71, there is a extrusion process. So there is two type of extrusion, hot extrusion and cold extrusion. Okay, these things you know, these things also you know. Then extrusion process, there is a container overall friction. There is a first container overall friction will increase present, the pressure will be generally develop cracks. Handling component heading and container friction dot no, this is not present. Impact friction on the extremely ductile material, impact friction will happen. Aluminum, lead, tin or gold. Variation of friction, there is a forward friction, fast, low, then increasing, and then here backward this increasing. And the butt formation at the end of the some material, there is a left part, and it is the cold fusion and hot fusion. I will not gonna discuss them. So E value A0 L0Y A0 L0Y ln A0 y A1. E is this value, total energy involved A0 L0Y into E1, and E equal to ln A0 by AY equal to specific energy for perfectly elastic material. So energy supplied is Y0 AY ln A0 by A1, and ram pressure is F by A0 into A plus Y. So ideal extrusion process Y ln A0 by A1, you know, ideal extrusion process YF ln A0 by A1, and Y is for perfectly plastic, and Y bar F is for sterile hydrogen material. Actual external load equal to actual load plus redundant load. Extrusion when there is a friction. When there is a friction, then P equal to Y plus 1 plus beta and 1 minus A1 by A0. P equal to cot beta alpha semi-diangle. You know all these things. External force, there is a Johnson equation, that is Y equal to A plus B into ln A0 by A1. A equal to 0.8 and B equal to 1.2282. Extrusion forces for host extrusion. Experiment done. External load equal to K into A0 into ln K into A0 into ln A0 by A1. Then this is the pipe defect, external cracking, more circle happened. Then there is a math. Then this portion there is a wet drawing, that is there is a three zone. There is a first is a deformation zone, that is the deformation zone. There is the entry of lubrication, that is entry of lubrication. 3 is sizing zone, this is sizing zone. 4 is exit zone. Okay, the main formula, you know these things, you know those things. Then equal to ln is AF giant 2 I for high diangle reduction cross section F of alpha deformation co alpha. Then this is optimum value sigma d, how it's happening. Types of lube, there is a no lubrication, there is a plug burnt mark will happen. Liquid lubrication, metric, dual lube, where, and solid powder lubrication, that is a silvery or shiny lubrication. Steps, rotary sagging, and all these things happens. And writing, there is a stress, there is tube drawing, there is a two type tensile, bucket type compression will happen. Okay, then flow stress, and flow stress value k into epsilon n plus 1 by n. Ideal drawing stress y by f ln a0y, same as almost strain curve. There is a strain heading component, there will be straight curve, so sigma equal to y plus h into epsilon. But here ideal drawing stress y bar af ln a0 by a1 for sigma strain hydering y bar af is a strain hydering and two type of things. And then constant friction sigma d equal to y bar f 1 plus beta by 1 minus beta a plus 1 minus a1 by a0. Okay, drawing load versus stress. then rigidly perfect reduction of construction. So how much reduction in construction? 63.2%. There is a sigma equal to y bar k into epsilon n. So this is the formula. Reduction is 1 minus e into 1 minus n. Solve numerical on these things. Okay, I think this is end of this whole. For me, there will be 5 to 6 units. I need to just make this 1 hour video. That's all. For 1 hour you have to need